Hello and welcome to C++ Weekly. I'm your host, Jason Turner. Want to remind you that I am going to be at a bunch of different conferences doing workshops this year, so make sure you check those out. They will all be listed in the video description. And that's going to be true even in later years, right? So just go ahead and check it out. Okay, I have some code here that has very clear, undefined behavior. But I'm not getting any output from my compiler letting me know that there's a bug in this code. And we're going to have one of these episodes that's probably going to make you comment like, wow, Jason was salty and annoyed during this one. We're probably going to get there. This week's episode is sponsored by HRT. If you've attended any C++ conferences this year, there's a good chance you've already heard of HRT, as they have sponsored several conferences. HRT is known for its deep engineering culture and strong focus on performance. And they are looking to hire the sharpest engineers to help them to develop and optimize the technology at the core of their business. They're headquartered in New York, but they have offices in Austin, Chicago, Boulder, London, Dublin, and across Asia. They're looking primarily for C++ and Python developers. I know, since you're a viewer of C++ Weekly, you are a C++ programmer, and you probably already program in Python too. So go ahead and check out the link on the screen for openings that they have. And remember, you don't need a financial background, just strong engineering fundamentals, and they'll teach you the rest of what you need to know. So what I have is this thing, this new integer I. So I is a pointer. And now I am passing ownership of I to the unique pointer here. This unique pointer's lifetime is going to be only for the length of this expression where that semicolon hits. So the use is going to have this temporary unique pointer basically, which means that the object pointed to by I is going to be destroyed right here on line 8. And then I am manually deleting it on line 9. This should be a double free. Let's point out a few things. First of all, I have address sanitizer enabled, which means I should be getting a runtime error from this. Execute code is enabled. I am not. Why am I not? Because the compiler managed to optimize away my undefined behavior. Thank you, compiler, for optimizing that away. Okay, I just switched to clang trunk. Clang trunk also optimized away this behavior and is also not giving me an address sanitizer error. We will go to 2, still being optimized away. 01, still being optimized away. 0, now I get the address sanitizer. Okay, let's go ahead and go back to our GCC trunk. I am also getting the runtime failure of this. Let's try turning optimizations back on. Notice at 01, GCC's address sanitizer implementation picks it up. And at 02, GCC's address sanitizer implementation picks it up. And at 03, it doesn't. It has been completely optimized away. Now, this is fascinating because when I created this particular episode and put it in my list of things to work on, GCC caught this at compile time instead of at runtime. Now notice I just turned on undefined behavior sanitizer as well, and even in 03, GCC now catches this bug. That's interesting. Let's see what happens with trunk of clang. So at the moment, no combination of sanitizers or not actually catches this bug at compile time. And the title of this episode was Finding Memory Bugs at Compile Time. Let's turn off the sanitizers entirely. Not surprisingly, the bug get optimized away at 03, and I get a double free at 00. All right, look at that. This is crazy. GCC 15.1, all right, with -03 and with -f sanitize equals address. So let's make sure we've got this dialed in exactly. I'm going to turn on both address and undefined behavior sanitizers. Yep, there we go. This is exactly what's required. GCC greater than or equal to 12.1 and less than trunk at the time of the recording of this episode with -03 enabled and -f sanitize equals address, I now get a compile time error for this use after free, basically this double delete here. So go ahead and add this to your build matrix. There are, shall we say, a depressing number of different builds that we need to enable on our CI to catch as many possible errors as we can. This is going to come down to, at this point, GCC clang MSVC with no optimizations, all optimizations, and lots of warnings as errors. The possible set of no sanitizers, address, undefined, address, and undefined, it would seem. That works out to 3 times 2, 6 times 1, 2, 3, 4, at least 24 different builds. Well, thanks for joining me for this episode of C++ Weekly. Be sure to subscribe, and we can talk about this stuff when you come to one of my workshops.